Hello everyone, welcome back to the second video here in this AP Stats series on Unit 3 and collecting data. In this video we're going to talk specifically about sampling techniques and also some potential problems that can arise when you're collecting a random sample. So without further ado, I don't want to give too much away. Let's jump into what we're going to do here. So when it comes to sampling techniques, we have three techniques that are good, two techniques that are bad. And what distinguishes a good sampling technique from a bad sampling technique is whether or not it produces a representative sample from your population. And in this case, to ensure that it is representative, we just need our sample to be random. So, like I said, there's 5 total. So, the first good way is what's called a simple random sample. The second good one is called a stratified random sample. The third good one is a cluster random sample. And we're going to talk about what distinguishes what distinguishes these from each other as well. The two not so good ones, a convenience sample, which you could probably imagine not so great, and a systematic sample. Systematic is the one that tends to get people because systematic sounds good, as if there is a system in place and we're doing things the right way, but a systematic sample is not random, so you have to be careful. There we go. Now, a simple random sample, if we cover that first. The word random is very hard sometimes to define because people always want to say that it follows no pattern or that there's no they always want to define it as the negative, but we have to define things what they are. So very simply, a simple random sample is any sampling technique that allows for every member of your population to have an equal chance of being selected. That's all the word random means. So the easiest thing I like to tell people is something like a raffle, right? Every raffle ticket in that bucket has an equal chance of being picked. So things like putting names in a hat, using a random number generator, rolling a die, flipping a coin, everything in that case has an equal chance. That's all a simple random sample is. There is no one set formula, but it's any procedure that would allow for every single person to have an equal chance. That's all. This is the easiest way to collect a sample, right? So one of the biggest advantages is that it's really easy to do, right? If you have a classroom, you just put everybody's name in a hat and pick out a name. The drawback, though, is that because we are just picking at random, you may end up with a sample that isn't necessarily representative. Now, what I mean by that is, let's say you have a population that is very high percentage one group and very low percentage another group. So let's say we have people who are like 90% Yankees fans, 10% Red Sox fans. It's very possible in a simple random sample that I end up with all Yankees fans just because of the makeup of the population, and based on this procedure, there is a very high likelihood that I end up picking a Yankees fan. And so I may, in the end up with a sample that isn't as representative as I want it to be. And so, to combat that, we bring in a stratified sample. Now, the biggest difference with a stratified sample is that we first group our population based on some common characteristic. And now, typically, this characteristic is one that we think will influence the answer to the question we're being asked. So, if this was a what's your favorite sports team, I'm probably going to group people by where they're from or where they grew up. If this is a question about your favorite food, maybe I do the same thing. If this is a question about politics, maybe I group people by the political party that they're affiliated with, because I think that may influence the answer. Once we do that, we then take a simple random sample from within each group. And this ensures that I get a representative sample. So that scenario that I mentioned before about 90% Yankees fans, 10% Red Sox fans, well, now I'll make sure I have representation from both groups. And additionally, in the end here, we want to make sure that our final sample is still representative of the total population. So let's take that same scenario of 90% Yankees fans, 10% Red Sox fans. If I had a sample of 100 people, I would want to make sure that had 90 Yankees fans and 10 Red Sox fans. I wouldn't want it to be 50 and 50 because that wouldn't be representative. So again, like I said, one of the biggest advantages of a stratified sample is that you're guaranteed to get that representation. However, one of the disadvantages is that it can be really difficult to do on a large scale. Now, for the purposes of AP statistics, that is not a huge deal. If they ask you how to design a study, you can stratify it. That is not a problem. It's not a consideration. This is more just a bigger picture thing. That's all. Now, for a cluster sample, this is where people tend to get things a little bit mixed up because a cluster sample is very similar to a stratified sample. If you notice here, we're still grouping people based on that common characteristic. However, in a cluster sample, you're now taking a simple random sample of groups, not from within each group. So the easiest example I can give to help distinguish the difference here is think about a high school cafeteria. A stratified sample, I'm going to go talk to 2 students at every lunch table. With a cluster sample, I'm going to select 5 tables and talk to every single person at those particular tables. So one of the advantages with a cluster sample is that it is very easy to conduct at a large scale if there's just data that you already know. So if we're trying to look at something like school budgets, something that's public information, it is really easy for me to do a cluster sample and pick entire states or entire counties within a state and look up that known information. If this was me actually trying to survey people, this would be incredibly difficult. If I was going to pick the entire state of Texas, I could not survey every person who lived there. But if it's already with publicly available information, then this really isn't very hard to do. It's actually a little bit easier than some other sampling techniques. The disadvantages, though, on the other hand, is that this may not end up being representative because we're choosing entire groups. Again, if you think of the scenario of we're going to group people by state or group school districts by state and then randomly select states, if I end up getting all states on the West Coast or all states on the East Coast or all in the middle of the country, I may not get a representative picture of the entire United States if I do things that way. Right? If I miss Alaska or Hawaii, things there may look very different than they do for the lower 48 states. And so you may end up with something that isn't as representative as you hoped. And like I said before, this is almost impossible when you're dealing with people. It's almost impossible to do. So this is also, this is just a visual for the difference between stratified and cluster. Stratified is on the left, where you notice we have people all grouped together based on some kind of common characteristic. In this case, it's color, whatever that represents. And I'm picking a random sample of people from each group. Whereas in the cluster sample, I've just picked 2 entire tables. And I'm going to talk to all 12 of the people that are at those tables. I end up with the same sample size in the end, just in a slightly different way. So I think this visual is a good one to show the difference between cluster sampling and stratified sampling. So a convenience sample literally is just you're going to talk to people because they're close to you. I'm going to give out a survey to the first 500 people who walk in the door. Bobblehead night at any Major League Baseball game is a convenience sample. It's not random. And because it's not random, I can't generalize to anybody, and it is not representative. A convenience sample is not what you want. The questions you'll see on the AP exam about this are going to be more centered around how to fix it, or what type of sample is this and why is it not representative. Um, you don't need to give a definition of a convenience sample. Now, the other bad one being our systematic sample. This is the actual definition from the course and exam description, where we select a random starting point and a fixed periodic interval. Think of it this way, that they try to make this sound good because we're going to randomly generate this number for the interval. But the problem is, as soon as you generate that number, your sample is predetermined. So if you pick every fifth thing, the seventh thing off the assembly line is never going to get picked. And so as soon as you select that random number, whatever that number is, your sample is predetermined. If that number is 7, the sixth thing is never going to be selected, or the 8th, or the 9th. And so it can be a problem not being random. It becomes a lot harder to catch issues, especially in like an assembly line scenario. Once again, this is not random. This is not what you want to do. So if you recognize that something is systematic, be looking for the question of, will this generate a representative sample? Or the question of, is this representative? Is this a good sampling technique? And then you'll be able to answer appropriately. Now, the other thing you may see are some potential problems in sampling. We have 3 types of bias. First type of bias is called response bias. Response bias, non-response bias, and selection bias. I realize here I'm going to get a little bit more into what each thing is here in a second, but response bias is essentially when people don't tell you the truth. They answer one way, but the true answer is something else. And the reason why I phrase it that way is that that's how you want to answer the question. If you're asked about response bias on the AP exam, it's that people are going to answer yes when the truthful answer is in fact no. So that's how you want to phrase your answer. Non-response bias is exactly what it sounds like, not getting an answer from someone. Now, typically that will happen in the form of like an email survey or a snail mail survey. Obviously, an in-person interview, a non-response bias is kind of weird, but think of it like someone pleading the fifth. They're not going to answer your question. And then selection bias is missing a part of your population, which is why it's also called undercoverage. One thing that's really important to note is that none of these are on purpose. I am not purposefully leaving out a part of my population. It just happened based on my sampling technique. Obviously, when it comes to response bias, as the interviewer, I'm not looking for people to lie to me. And again, non-response bias is not on the researcher's part. You just didn't receive an answer from someone. And so, how do we mitigate that? Response bias, very simple. You can make things anonymous. That is the easiest way to do that. There was an example FRQ where they had an environmental science teacher interview students about recycling plastic bottles. You're probably going to answer yes because it's important to the environmental science teacher, even if that answer is no. So if we made that an anonymous questionnaire, life gets a lot easier. For non-response bias, I always say hunt them down, but in reality, it's just follow up. If it's an email survey, make a phone call, go knock on the door, something along those lines. But really the answer here is to follow up. And then for selection bias, stratify. Right? If we stratify our sample, we're more likely to get that representation that we're looking for. And the cure-all for all of this is to increase your sample size. Now, what is important about that? That means you scrap your original sample and then you redo it with a larger sample. So I took a sample of 100. I suspected there might be bias. I'm going to scrap that, throw that data in the garbage, and then redo this sample with a sample of 500 people or 1,000 people instead. So the last thing we're going to look at here is an example. right? This is an example. If you're a student of mine, we did this example in class, but it's about requiring students in elementary school to attend school year round. And so they sent this out to 500 people. They only got 98 responses back. And 76 of those indicated support for year round schooling. Okay, great. Now, one thing here, what is a possible consequence is like an actual action that will happen. So in this case, if they interpret this, right, they're telling you this is non-response bias. Obviously, 402 people did not respond. They're going to implement year-round school when in reality, the majority of people may not support it. So that's important, number one. Part B wants you to combine, right? We're going to take an additional sample and combine the results. This is why I was saying increased sample size doesn't just mean add on to your original. This would not be a suitable solution. And the reason for that is that once you have a biased data set, it is forever biased. It's like the scarlet letter. I cannot use it. And so take that advice, throw it in the garbage, take that data, throw it in the garbage, and redo this completely with a second set of 500 families if that's what they wanted to do. So the more suitable thing for part C would either be that, or to go ahead and follow up with the 402 families who didn't respond. If you read this question closely, it just says sends a survey. It doesn't say how, but I would imagine whether it was email or postage stamp mail, this was not something where they were calling people. Even if it was a phone survey, they have the information for these people. They can go knock on the door and actually get a response from them. So it's either scrap it completely and start over, or follow up with the 400 people who did not respond. So again, I hope that was helpful, and I'll see you in the next one.